This is section 4.3. A couple of things on this. One, the first thing I believe that you guys are all very familiar with, and that is the distribution property. So if we have, and I'm looking at example number 1 on page 174, if we have this small, or not small, but if we have this polynomial here, 2x plus 3 parentheses times x squared plus 4x minus 5. This is distribution property, a distributive property, that we take the first term times the first term times the second term, first term times the third term. We also take the second term times the first term, second term times the second term, second term times the third term. We can also rewrite that as the book does by saying that this is 2x times x squared plus 4x minus 5 plus 3 times x squared plus 4x minus 5. That results in the same thing, and I encourage you to think of this either way that you would like to think of it. It all works. If we do this multiplication either way, whether it's up here or down here, the expanded product is this entire thing. Now, what I would suggest you do is by checking the upper over the polynomial, is check and rewrite by grouping like terms from the highest degree, that is the highest exponent, down to the lowest exponent. So let's look at the third degree expressions here, and we only have one. That is 2x to the third. Check it off. Let's look at x squareds. That's here, 8x squared plus 3x squared. Positive, positive, that is plus 11x squared. Now go to the first degree, which is negative 10x and positive 12x. Be careful. Negative 10x plus a positive 12x is plus 2x. And if we look at our check marks here across the top, we are only left with minus 15. And that is the product here. That is simplified, that is multiplied. And that is the distribution. Now, there's another example that you should look at. And there is another way to do this. It's called vertically in the book, and you can do it that way. So there's 3 real ways to do this. Now, what I want to do is grab myself a clean page and go to the special products that's really the heart of this section of page 175. This material's on the top of page 175. It's called special products. Now, here is the goal of really this section. And these are special products, meaning that these are a kind of unique expressions that you're going to see over and over again in Algebra 2, in this class, future classes, right up on through calculus. To understand and by inspection, that is by looking at these, and this is a little bit of a shortcut that we're trying to teach you. So these 3 expressions, here is what is special or unique about this. This is a polynomial a plus b, so we're writing this a plus b times itself twice, hence squared. This expression is a minus b times itself, and this expression is the variation. If these are both positive up here and these are both negative, then let's take one of them positive and one of them negative. Now, what these special products are is just that. If I do the distribution here, like we did in the previous slide, we can certainly have this written in expanded form, but what we want to do is get you to be comfortable with this. By inspection to say, okay, this is positive squared. We're going to take the first term, which is a, square it. The last term is b, and square it. And what I'm going to do is take both of these terms, times each other, times 2. 2ab plus b squared. That is, in fact, the product here. When we have the second one here, we do something similar. We take the first one, a, square it. Take the second term, b, square it. Now, because this is a negative, we're going to go minus a times b all times 2. So it's minus 2ab. The third variation, if you will, is one of these is negative, one is positive. I said that backwards. So what is going to happen here, and I'm going to write this one out. This is a times a, which is a squared. It is a times a negative b minus ab. And then we go here, we're foiling, of course, ab, but it's positive ab, and b times negative b, which is minus b squared. When we have this situation like this, it is a special product. You'll see that ab positive, ab negative cancel each other out, and we're left with a squared minus b squared, which is always referred to, and you will want to recognize, as a difference of two squares, or a difference of perfect squares. And that's a key thing. You're going to see this all the time, very frequently. Now, let me grab a clean screen and we'll do some problems. So here I have 4 problems. I'm trying to get one that represents everything that we did in the previous slide here. So we have 4k minus 5 squared. So by inspection, which is what I'm trying to emphasize here, that we see this is minus. What I want you to try to see is that I'm going to square the first term, which is 16k squared. I'm going to square the last term, careful, which is minus 5. So squaring it is plus 25. Now what is the middle term going to be? Well, it's going to be negative a times b, which is negative 20k times 2, which is negative 40k. Of course, when you do that out, you will get the same result, and I'd ask you to do that on your own. Write this entirely out and expand it using the FOIL method. Here is our second one, which is 3x plus 10, quantity squared. Now this is a positive, so everything in here is going to be positive. Take the first term, 3x, and square it, which is 9x squared. Take the last term and square it, which is 100. The middle term is going to be a times b, which is 3x times 10, which is 30x times 2, which is plus 60x. The third one. Now these are both positive. One is positive and one is negative. Sometimes the FOIL method is the best here. So 7t times 2t is 14t squared. 7t times a negative 1 is a negative 7t. 2 times 2t is plus 4t. And a positive 2 times a negative 1 is minus 2. Combine like terms, and we get 14t squared minus 3t minus 2. And the last one is the one that I like the most, and that you will frankly see quite a bit. This is a difference of two squares, and by inspection, the middle terms are going to drop out here. So this is going to be the square of the first term. P squared times p squared is p to the 4th. And the last term is going to be negative, because we have a negative times a positive here, but it's going to be the square, which is minus 4q to the 4th. Done. Now all of these, every single one of these can be done using the expanded FOIL method. That is totally fine, but I want you to appreciate that eventually You will want to, believe me, be able to do this by inspection because it saves you time. Please, if you have any questions on the homework on page, or the written exercises on page 176, give me a shout out. I'm happy to do a separate video on any of those separate problems. Good luck.